All right, guys, we are in Unit 9, and this is Day 6, and we're going to talk about imaginary numbers, okay? We've talked a little bit about them in that when you take an even root of a negative number, most commonly a square root of a negative number, you get an error message in your calculator that says non-real. Non-real is the same thing as imaginary, okay? They also call them complex numbers as well. All right. So recall that in the real number system, it is not possible to take the square root of a negative quantity. Okay. So in number 1, it says on the axis below, a sketch of y equals x squared is shown. Now consider the equation given as f of x equals x squared plus 1. All right, so the difference between the first equation they gave me and the second equation that they gave me, first off, we know f of x is the same thing as y. All right, so that's not really the difference that we're talking about. We're talking about that plus 1. And what that plus 1 is going to do is shift the graph up 1 unit. Okay, so if we go ahead and we sketch that, if this is our turning point and that gets shifted up 1 unit and all the points on that parabola get shifted up 1 unit, you can see that our new graph would look maybe something like that instead. Okay, so part A says how it is the graph of y equals x squared shifted to produce the graph of f of x, and we're going to say it's shifted up 1. Okay. Part B says create a quick sketch of f of x, and so this is our f of x, and we've already kind of did our sketch of it. Part C says what can be said about the x-intercepts of the function y equals f of x. Well, now that it's shifted up 1, it doesn't touch the x-axis, and therefore we're going to go ahead and say that the x-intercepts don't exist because it doesn't touch the x-axis. Okay. So does that mean there are no x equals or solutions? Well, not any real ones anyways. All right. So in part D, it says algebraically solve x squared plus 1 equals 0 so that we can algebraically find the x-intercepts. Even though we don't see any x-intercepts, there aren't any x-intercepts. There's no real x equals, but there are imaginary. And so in part D, when we have to solve this, this is not a D2PS, so therefore we cannot factor it because that's a sum of 2 perfect squares, not a difference of 2 perfect squares. So the only thing that we can do is subtract the 1 over. And we end up with x squared equals negative 1. And to get rid of the square on the x, we know that we square root both sides, right? And so the square root and the square cancel, and we are left with x equals the square root of negative 1. And if we type in the square root of negative 1, this is non-real. Okay, what we're going to learn is that the square root of negative 1 is actually called I. Okay, and because we square rooted both sides of that equation, this is technically a plus minus in front of that square root of negative 1. And so there's a plus minus in front of our I. And so we end up with x equals positive I and x equals negative I. And you're going to notice I write my i's a little bit differently because I don't want them to look like ones, all right? So we put a little kind of curve to them when we do it, but it doesn't matter how you write yours, all right? But these are imaginary, okay, also known as non-real solutions. Okay, and we get those when parabolas, okay, or quadratic functions do not touch the x-axis, okay? They have no real x-intercepts, okay? However, they do still have solutions. They're just imaginary or non-real solutions, okay? So a little bit confusing and abstract to our mind because it is something brand new that we're not used to. So it'll take us a little bit to get used to the idea, okay, and how this is all connected. All right, so it says, since we cannot solve this equation using real numbers, we introduce a new number called I, okay, the basis of imaginary numbers. Its definition allows us to now have a result when finding the square root of a negative real number. All right, so this right here is something you're going to have to 100% know. Okay, it's just the definition of the imaginary number I, okay, and I is always equal to the square root of negative 1. Okay, all right, so in number 2, Now that we have that introduced, if we are asked to simplify square roots with negative numbers underneath them, instead of just seeing that the answer is non-real, we can actually have an answer. However, our answers will have i's in them, okay? All right, so in number 2, if we think about the square root of 9, the square root of 9 is 3. So the square root of negative 9 would be 3i. All right, so this is how I kind of think of it. I always break it up into 9 and then a negative 1, okay? 9 is going to give me the 3, and the square root of negative 1, remember our little rule up there, is I. And so we end up with 3i, okay? So let's try another one. Square root of 100 is perfect. Square root of negative 100 is going to be an imaginary number. So again, I break it up into 100 because it's perfect, and negative 1. So that 100 times negative 1 is negative 100, and I still have what I began with, okay? I go back and I think of the square root of 100 as being 10 because it's perfect. And the square root of negative 1, again, going back to our rule that the square root of negative 1 is equal to an I, this becomes 10i. All right. What about a not perfect one? 32 is not perfect. And so what I do here is I break it up into 3 square roots. Okay. The largest perfect that goes into 32 is 16. The other number would be 2 and the negative 1. Okay. So that if I do 16 times 2 times negative 1, I still get negative 32. So it's equivalent to what I began with. But the square root of 16 will become the 4. The square root of negative 1, going back to our rule, it becomes the I. And then the square root of 2 is not perfect and stays in its radical. And now we have an answer of 4i radical 2. Okay, let's try one more. 18 is not perfect. And so we're going to break it up into 9 and 2 for the 18, and then the square root of negative 1. So that if I do 9 times 2 times negative 1, I get negative 18. So I didn't really change anything, just changed what it looked like and broke it out. Okay. And now we'll go back and we'll circle our perfects. So square root of 9 is 3. The square root of negative 1, according to our rule up here, is I. Okay. And then the square root of 2 is not perfect and stays. And there we end up with 3i square root of 2. Okay, so another thing that we have to learn and understand is the powers of I. Okay, powers of I display a remarkable pattern that allow us to simplify larger powers of I into one of 4 cases. And so you guys are going to see this pattern happening before you. All right. So in number 6, we have learned way back in when we were talking about exponents that anything to the 0 power is 1. Okay, so that's an easy one. So is number 7. Anything to the first power is itself. Okay, which is going to be I. Okay. Number 8 is going to be a little bit tricky. Okay, we have to think about I squared. All right. And so we end up kind of thinking in this sense. Think if the square root of negative 1 equals then I squared equals what? So for instance, if I take this side and I square it, that's how I'm going to get the I squared. But if I square that side, I also have to square this side, right? And what's going to happen is that the square root of the square root there and the square will cancel each other out, leaving you with a negative 1 is equal to I squared. And so now we can say that I squared equals negative 1. And this is going to be something that you have to kind of memorize. That one is going to be used a lot. Okay. All right. So then we end up with I cubed. Well, I cubed can be thought of as I squared times I. Because what you do is when you multiply, add the exponents. And so if we end up with that 2 here, and we add that exponent of 1 here, we get that exponent of 3 there. Okay. And why we broke it up then to that is because I squared was already figured out up in number 8. And so that's going to get replaced with a negative 1. Okay. Times I to the first, we already know from number 7 that I to the first is just an I, and so I to the first gets replaced with I. Well, negative 1 times I is negative 1I, which is really just negative I. And so I to the third is really equal to negative I. Okay? Following me? Don't worry. We'll put these all in a table so you guys can see the pattern in a few minutes, okay? But we have to finish our 3 more that we have here. So I to the 4th can be thought of as a few different ways, okay? Easiest way, though, to think of it is I squared times I squared. Because when you add the exponents, you get 2 plus 2, which is 4, okay? And the reason why I broke that up into the same 2 so that I can replace them with the same thing. So going back to number 8, remember we already figured out I squared. I squared is -1. So we're going to replace this I squared with a -1 times this I squared, which is going to become a -1. And -1 times -1 is +1. Okay? All right. So remember I to the 4th is equal to 1. All right. So 2 more to go. I to the 5th. So we're going to break I to the 5th up. And there's a couple ways you can break it up. Okay? I'm going to break it up into I squared times I to the 3rd. Okay, so that if I add my exponents there, I get my I to the 5th. All right, here we go. We're going to replace them. So I squared all the way back up in number 8 is -1 times I to the 3rd, which is in number 9 here. Remember, I to the 3rd is -I. And negative times a negative is positive, and 1 times I is just I. And so now we have I to the 5th equal to I. All right. Okay, one more. Bear with me. Okay. I to the 6th. Easiest way to break it up into is I to the 3rd times I to the 3rd. So that if I multiply my I to the 3rds there, you add the exponents, and 3 plus 3 is 6. And that's why that's equivalent, okay? All right. And I broke it up into the same thing so we can replace them both with the same thing. And I to the 3rd back in number 9, remember I to the 3rd is equal to -I. So we're going to replace this I to the 3rd with -I. We're going to replace that I to the 3rd with -I. And a negative times a negative is a positive, and I times I is I squared. However, back in number 8, I squared is equal to -1. And so now we end up with that, okay? So I'm not going to go ahead and continue not continue my video. I want it to actually use this so you guys can see on the next page. Although I can't see this on the next page. So what I'm going to do is, in summary, before I go to the next page, in my next video, I'm going to go ahead, guys, and show you the pattern that I to the 0 equals 1. Okay, that I to the 1st equals I. That I to the 2nd equals -1. And that I to the 3rd equals -I. Okay. Now I'm going to show you that I to the 4th equals 1. That I to the 5th is I. That I to the 6th was -1. And guess what, guys? We didn't find I to the 7th, did we? But do you see the pattern? We already know that I to the 7th is going to be -I. And now I can find I to the 8th. I to the 8th is going to be 1. I to the 9th is going to be I. All right. And the pattern continues every 4. So I'm going to show you guys that in the next video on my table. All right. All right. I'll see you guys there.